The basic RTM process involves injecting a resin through reinforcement placed in more substantial rigid tooling manufactured from composites or metal. RTM can offer distinct advantages, particularly if temperature-controlled tooling is used. Increased productivity through the use of higher injection pressures and heated molds. Improved quality. Improved product consistency due to better process control. Improved dimensional tolerances. The mold is gel-coated by either hand or spray application. Because of the use of heated tooling, the reinforcement can be laid onto the gel coat far quicker than at ambient temperatures. A surfacing veil or fleece material, as shown here, can be used to reduce the glass print-through. Once again, deformable stitched mats, such as Rovicor, offer distinct advantages in glass loading. Core materials may be incorporated, but their dimensional accuracy is critical to the success of RTM. The mold is closed and clamped using bolts, toggle clamps, or sometimes a press. Liquid heating is used to ensure consistent temperatures. 40 degrees C is a typical mold temperature. The mold is vented at the point of final fill. Resin is injected from a central point at typical injection pressures of between 2 and 4 bar. Machine options such as the mold pressure guard, or MPG, ensure that the injection is controlled and that the molds are not overpressurized. It would be expected to see a small amount of resin at the vents to ensure that the mold is full. Once injection has been completed, the injection head is removed, a stopper is placed in the injection hole, and the machine flushed with solvent. Once the resin has cured, the mold is opened and lifted to allow demolding. The heated tooling allows quicker curing of the resin, and so quicker cycle times are achievable when compared with ambient temperature processes. RTM can use metal molds such as nickel shell, aluminium, or steel for maximum durability and improved surface finish. However, the principles of the mold design and the process remain the same. Further automation can be achieved using auto-sprue technology. This valve is built into the mold and allows simple connection of the injection machine. At the end of injection, the auto-sprue automatically flushes the machine with solvent, and then the machine can be easily disconnected. Once the part has cured, then it can be demolded, leaving the mold ready for the next component. The use of RTM can be limited by the higher cost of tooling, the cost of an injection machine, but also by the gel time required for mold filling, which limits productivity in very high volume applications. However, RTM is now a proven technology for fast and efficient production of GRP components.